What's going on, everybody? In this video, I'm going to give you a no-frills practical way to use Regex in Make.com. I currently run a Make.com community with 400 members, and one big thing that's come up over the course of the last few weeks is, hey, how the heck do I actually use all this Regex stuff to parse data? So if Regex is something you've personally struggled with in Make.com, this is the video for you. I'm going to guide you through a bunch of practical examples and practical ways you can use it, not just dry academic theory. Let's get into it. All right, so first of all, what is Regex? Well, Regex stands for regular expression, and I have been yelled at many times in this channel because of how I pronounce it, but essentially, it is a sequence of characters that specifies a pattern in text. And in Make.com, what you do in order to use it is use this text parser or match pattern module. So you go down here, you scroll down to match pattern, and this is the one that you use. The cool part about regexes and why people love them so much is they basically allow you to create a set of rules that if your text exists in the input that you feed into it, can match specific strings and specific patterns of characters. And it's not just like matching the same text over and over and over again. Like, you know how on your browser, if you hold Command or Control and press F, then type in a word like pattern, it'll find that exact word for you, right? If it's present. Well, regexes allow you to, instead of using a specific word pattern, say, hey, I want to look for something that starts with the letter P and then, I don't know, has like any character in between, and then it needs to have two T's and then an E and then an N. And, you know, if that exists, then regexes, the regex that you create will allow you to find that. You can imagine how that very simple example can be extrapolated and sort of expanded to cover basically anything you could possibly want it for. And what I personally find regexes are super useful for in Make.com is to find things like URLs, to extract lists of email addresses from websites, to find specific patterns and strings that may not be formatted the way that you want to find names, to pull out details, contacts, customer information, keywords and email addresses, resumes, and that sort of thing. So if you master the use of regexes, if you learn how to use regular expressions in your Make.com flows, you'll be a lot more powerful and just a lot more adept of a power user, I want to say. So what I have over here is I have 4 very simple examples, and I haven't actually done a lot of prep in any of these examples here. I'm just going to sort of do it and wing it as we go along. The reason being is because I want to show you how I personally approach regexes when I'm faced with them. I'm not actually a regex pro. I probably consider myself like very much in the middle, in the median 50th percentile here. I used them a little bit when I was programming, but when I started, Make.com and I started really diving into it, I never really had to expand my skills because of a few very simple tricks and techniques that I'm going to show you here. The cool thing about regexes is you only need to know like 3 or 4 of the little patterns off the top of your head, and then you can either consult resources that are sort of like regex games, which I'm going to show you in a minute. One's called Regex 101, or you could use AI to answer a lot of those regex related questions for you. And I just have a little Claude Sonnet instance open over here, which I'm going to be using to help me build this. But yeah, we're going to start with the simplest examples and then just work our way up in terms of complexity. And this is going to cover what I would consider the vast majority of the landscape to be. Once you know how to do all 4 of these, if you just put in a little bit of hard work and some elbow grease, you should be good for more or less anything. Okay, so let's start here with the very first example, basic letters cat. So what I have here is I have a set multiple variables module here with a variable called regexme. With the value, the quick brown fox jumps over the lazy cat. A cat, with a capital C, is different from a cat, lowercase, but a caterpillar is not a cat at all. Okay, so what we want to do is we want to find the presence of a cat, essentially. We want to find the cat inside of this. You can imagine how, I don't know, we are looking for some keywords in either a resume. Well, maybe a resume isn't the best example, but this is like maybe a book passage, and we're feeding as input in a book, and we're just looking for the presence of a specific set of characters. What we're going to do is we're going to feed this into our text parser over here. So I'm going to use this as the input. And then I'm just going to put in like a basic input here for now because I want to show you guys how to use Regex 101 and how I'd approach this. But you'll notice that there are a bunch of settings here. There's global match, case sensitive, multi-line, single line, continue the execution of the read even if the module finds no matches. These are all just different configurations of the regex, which I'll show you. And basically all of these, according to the regex language, because regex is basically a language, these will change the way that this works. Like if you do global match, for instance, it's as if you have another string attached to the end of your regex. That's something that really confuses a lot of people, and I'll explain that in a moment. But okay, great. So if I have this, what's my actual workflow? What do I personally do when I build my flows? And I've made tons of money with Make.com. Let me show you exactly how somebody that has done that would proceed. I'd go on a website like Regex 101. Or I just type in regex tester over here, and you'll see that there are a bunch of these. Tester, debugger, whatever solution you want to use. They basically do the same thing. They enable you to paste a text string down here, and then they allow you to play with the expressions up top in order to find, the string that you want. And this is just a much faster way of doing regex than testing it inside of make.com. If you test it inside of make.com, you're going to have to run, then you're going to have to look at the results, then you have to go back and run, look at the results. You're going to be wasting operations, and it's just going to take like 100 times the amount of time. So what I do is I open up regex 101, and then I paste in whatever string, an example input for the string that I'm looking to source. So, most of you guys are probably going to have dynamic inputs. You're going to have different inputs coming in every time because you're calling some resource or doing some API call or watching an email or whatever. Just get an example of an input that has the string character that you want, and then use that to feed in what you're looking for. Once you've done that, we can actually start building the regular expression. Now, the cool part about regex 101, and one of the reasons why I like them so much, is because on the right-hand side here, they have this quick reference. If we go down here to common tokens, you'll see that they've actually, and I know my face is sort of covering this. Let me see if I can zoom way out maybe. Okay, that definitely doesn't work. You zoom in a little bit. Oh, I know. We're going to drag this all the way over here. Okay, let me just do this. As you see down here at the bottom, we have a bunch of common tokens. So there's a, single character of A, B, or C. If you want to match A, B, or C, what you need to do is you need to do a square bracket and then the letters A, B, or C. If you were to put this in, it would match one instance of A, B, or C. If you were to use a square bracket and then type in this up caret and then go A, B, C, it would look for any characters except A, B, or C. So what I'm going to do here is I'm actually going to try this out on a couple of regexes. I'm going to do this right now. I'm going to put in these brackets and then I'm going to match the letter A. And let's just see what happens. If you type in this, then you say, match the letter A. What this will do is this will look for every instance of A in the string. Now, I'll talk about why it's looking up every instance. It's because we've set the global flag. If I remove the global flag, it'll actually describe the first instance. But let's just do global because it's a little easier to see how this works. But basically, this is just one of the many programming rules that regex allows you to engage with, right? Square bracket and then any string inside, like let's say UIC or something, it's going to match every one of these letters, but it's going to do it individually, okay? Now contrast that with if I were just type UIC. If I type UIC, it's going to match the entire UIC inside of Quick. Whereas if I type bracket UIC, basically the inherent logic here is match U, I, or C, whatever one of those characters comes in, which is why we all of a sudden we're matching U, we're matching C, C, U, C, I, right? We're matching a bunch of characters inside here. But what does a match really mean? Well, as you see right here on the right-hand side, there's like match 1, match 2, match 3, match 4. In make.com, when you match something, what you're really doing is you're returning it as a variable that you can then use later on. So if I were to do this myself, right? Let's see, what did we do back here? UIC. If I were to pump now this into make.com, and then if I were to run this flow and just ignore the warning about the transformer, look at what we end up getting. Basically, every single time we make a match, we're going to get two things. One, we're going to get the index or the number of the match. So this is the first thing that we match, the second thing, the third thing, the fourth thing, the fifth thing. And then we're going to get the actual character that we matched here as well. And you'll see that we actually ended up matching 13 different things. So we've received 13 different bundles. As you can imagine, it's probably not that valuable to have things laid out like this, because every time in Make you have more than one bundle, you're going to run every subsequent scenario more than one time. But I'm just showing you this just so you guys get a little bit of familiarity here. The term match really just means, hey, we're going to see this output in make.com when we run it. And the value there is you can obviously use this in your flow, right? You can look and see, if cat is present, then do something else. Okay, great. So we've covered a couple of the basic characters here. What I want to do next is I want to show you guys my personal favorites. Easily my simplest and most personal and most commonly used character is this dot character, because that matches any single character in your entire string. So if I just type a dot, for instance, it will literally match everything. It's going to match the characters, THE, it's going to match the white space in between, it's going to match the periods, the punctuation, literally everything. Okay. And I actually end up using this very, very often in my own regexes because it's just sort of a placeholder character. You might be thinking, Nick, why the hell would you want to match everything? But I'll show you why in a second. Let's hypothetically say that what I'm looking to match is I'm looking to match any character, and then I'm looking to match any character, and then the letters H and E. if I were to type this in, and this is now a placeholder that allows me to match any instance of the, whether it's like uppercase the, lowercase the, or whatever. You can imagine if we had like something else like ash or something like that, it'll match the S in the string as well, right? I don't really know what other words or characters or strings start with that. Okay, so instead of me just staring blankly into space for 5 minutes, we're just going to do a different example. Let's pretend that it's any character and then an S, for instance, right? We could do as, we could do as, we could do is, we could do ys, us, right? It'll match basically all of these. And this is really where like the power of regex has come into play, because if you know one or more of the characters in the string that you're looking to match, like in an email, for instance, which I'll show you guys how to do in a second, you can basically like parse out the rest of it. And in this way, you can get a very structured response. Now, I usually don't just use this period in isolation. What I'll do is I'll use it with another character. And this is probably like the single highest ROI, most common regex pattern that I'll use. I'll use this star. What this star does is now I'm not just trying to match any one character. What I'm doing is I'm matching any character any number of times. So I know that this may seem a little bit weird to you, but let me give you a practical example here. Let's say I'm looking for this. I want a space, and then I want any character, and then I want a comma. Okay. What it's going to do is it's going to grab anything. Okay, actually, let's do this then. Let's do a space. Okay, we'll do a, and then we'll do a space, and then we'll do any character any number of times with a comma after it. What this basically allows us to do is it allows us to look for a pattern where it starts with this a character, then has a space afterwards, and then matches any number of characters in between, as long as it ends with a comma, right? You can imagine how if we're looking for like an email address or something, it's really easy to do something like this. And voila, we've now matched an email address. Why? Because we're looking for any character any number of times, and then an at, then any character any number of times. Then because the period is a protected character in regex, you have to escape it. That just means you have to add one of these in front of it if you actually want to match the period character. Then we look for the actual presence of a period, and then we look for some ending over here. You can imagine now if you wanted to stretch this and make this maybe not just .com, maybe you wanted to do my website, leftclick.ai, you'd have to change this up a little bit. Instead of .com, you'd have to go, something else. You could also store any number of these. You could have like, let me see here. There's a regex token or character, which allows you to match either one thing or another thing. So maybe we could do .com or AI like this. And I'll show you what the bracket character means here. But now we can basically match either Nick at google.com or we can match Nick at leftclick.ai. The point I'm making is there's just a variety of different ways to approach a regex. And I hope now that I've given you guys at least a toolkit that you can use to actually go out and build yours. Because this is exactly what I do every single time I'm approaching the regex problem. It's exactly what I did when I was starting out with regex, exactly what I do now as somebody that, builds regexes on a daily basis. Okay, so that was a mouthful, and I know we went a little bit away from our initial example, which was just us trying to find the character cat. But you can imagine how, if you want to find the character cat, you'd basically just type in cat, okay? So let me show you guys what that looks like if you try and look for the pattern cat. There are a couple of gotchas here. If I run this, and then I open this up, what you'll see is that basically we match every instance of cat. Okay. And that may or may not be valuable to us. But we have a little hack that we can use here to, instead of making it 4 bundles, we can get much better information. If you just write a left open bracket and then whatever you're looking for, and then a right open bracket, and then you run, you end up with the actual character that you found over here, which is quite valuable. And then right now, we're searching for all of the we're basically searching for all of the instances because we have global match on. But if I just wanted to see if cat was present, all I would have to do is I'd click global match off, and then I'd check this out. And then basically, if we find cat, we'll have cat visible to us in the bundle selector. And then if we have that, well, now we can, use this to do our logic. We could say, I don't know, cat exists. Or we could say cat, and then we could say exists. And then down here, we could say cat does not exist. We could say cat does not exist. In this way, we're now building in a little bit of logic to our flow, and we can use regex as basically as like a permissive, like, hey, is this here? Is this not? If it is, then we'll do something. And then if it isn't, we'll do something else. So a very common design pattern over here for cat. But obviously cat isn't a very realistic example, because why the heck would you want to just like verify the presence of a a string of characters that you know of? Couldn't you just do like, find and replace, right? Like, couldn't I just like hold Command F, type cat, and then like, if it is there, then it's one thing. If not, then it's another thing. There are multiple other modules here that allow you to do stuff like that. But we're using this match pattern regex one. So obviously, why don't we like dial this up a little bit and use regex the way that is meant to be used? So I have a hypothetical scenario over here, and I'm just going to, I'm just going to like write a bunch of random characters here, and we're just going to pretend that this is some database that we're calling with a bunch of random strings. And we're looking for the presence of a particular ID in this database, okay? Kind of contrived example, but we know that the IDs start with the letter A1F, and then they have a bunch of other information afterwards. And basically, if the ID starts with the letter A1F, we know that it's valid. And then if it doesn't, then we know that it's not. So A1E would not be valid. A09 would not be valid, but A1F, this is valid. And what we're looking for is we're just looking for this whole ID here. Okay. So how do we actually go about finding this? Well, I'm just going to copy this here and I'm going to paste this down here. And then you can think about it right now as if we're looking for the presence of the A1F character. Then, there's a bunch of other characters we could pick. If we knew the pattern of this and we knew that they were all going to be lowercase a to z and then numbers, 0 to 9, we could theoretically write, let me see, 0 to 9 or a to z, I believe. We could add as many of these as we wanted. And that way we'd always match, basically, we'd match this particular string over here. We could also, like the quicker and easier way, like what I personally would do is I'd probably just do this. I'd go select everything. But then notice how right now it's selecting all of the string, basically from start to finish, because this matches any character, including line terminators, right? Sorry, new lines and new spaces and stuff like that. What you can do instead is you could add a question mark to the end of this, I believe, and then a period, and then a space rather. And now you're selecting everything here. The reason why is because we're looking for a string that's formatted with A1F. Then we're looking for however many characters afterwards. But what this question mark does is this question mark is called the non-greedy quantifier. So basically it stops you at the shortest possible match that satisfies your search. If we didn't add this question mark, the shortest possible match of our search would just be A1F, because this character is basically 0 to an infinity number of any characters. Like that's what this little string here does. So just doing that will try and match just that little string, right? If we do a space though, then basically we're saying we want you to match everything up to and including this space. So let me give this a quick little try and actually pump this in. I'm not entirely sure if this is going to work, but we'll give it a go. Why don't I just feed in the actual string here? Just like that. Just give it a run. And we see that we did indeed have a quote unquote fallback match here with the presence of our string that we're looking for. Now, what I'll always do every single time I make a regex is I'll always wrap it in these curly round brackets. The reason why is because I end up getting this value over here, which is always like a $1. And it's just a lot easier for me to map that. Otherwise, you have to use the fallback match. And the cool part about these brackets is that you can actually create like a name for the match that you want. Let me just check out named match group regex. One sec. So you need to do a question mark and then the name. So what we're going to do over here is we're going to question mark name. And then I'll just call this, ID. And the value here is if I run this again now, you'll see that the output actually has a key with the pattern that I provided back there, which is ID. If I said Nick's awesome ID, well, now the variable name itself is going to be Nick's awesome ID. And this is tangentially useful. You can imagine there are some situations in which you want to call a dynamically generated key. But yeah, this allows you to do that. And I find it's just a lot cleaner and easier and more documentable, basically. But anyway, let's just keep it small and short and hacky. That's a very simple second example. If I were to now move this over here to what I'd consider a more business adjacent example, let's say we have a bunch of strings with valid emails. So john.doe@example.com, jane_smith123 at some subdomain, user at host.org. Basically, we're just testing a bunch of text and seeing if we can extract all them sweet emails. So if we want to match this, it's going to be a little bit tricky, and we're going to have to learn a couple of things that we haven't talked about so far. What we're going to do here is previously, I would probably try and just match everything with this dot and then this sort of star asterisk here. But for instance, if we're trying to grab all of the email, like let's just go john.doe@example.com. Right? This is a specific instantiation of an email, but it's not every email. If you wanted to grab every single email here, you'd have to know what the email rules are, how emails have to be formatted by both the mail providers and by the various services that work with these mail providers. And it turns out that the way that emails are formatted, and I only know this because I've done a bunch of email parsing in my time, but it's basically we can parse any character between lowercase a to z, uppercase a to z, and then the 0 to 9, including underscores and then periods as well. And this is the pattern that matches, like in order for an email to be valid, it needs to just be somewhere between lowercase a all the way to lowercase c, uppercase a all the way to uppercase c, and then numbers including an underscore and then a period. That's it. You can't have an email otherwise. You can't have any other, like it's not considered a valid email if you structure it in any other way. So if we do this and then we do an @ well, there's a problem there. Why is there a problem? Well, because the way that we've written this so far, it's only looking for a single character. It's basically saying A to Z or 0 to 9 or underscore or period, any character that exists there. So what we need to do is we need to do an exclamation or an asterisk here. And now it'll capture all of the characters, basically any one of these as many times as possible until we reach the presence of this little @ sign. Same thing with the domain here. Basically do it as many times as possible. Then we go a period, and then I believe TLDs can only be A to Z. Well, I guess they could also be capitals. Somebody like really screws up the writing or something. And then let's go this, and then we'll go, and then we'll go like this. This should cover, I believe, like 99% of emails, something like that. It's going to cover the vast majority of them. There may be some specific edge cases where, I don't know, there's like some different characters that some emails use or something like that. But this is personally what I will use when I'm regexing emails, simply because it just tends to work for basically everything. And you can see in this case that we've captured all the emails. If I were to like change the string, then go like nick@leftclick.ai, you see that it doesn't actually like pop up until I finish the whole nick@leftclick.ai. And also I could add a bunch of other characters in between, and then I could say hello@gmail.com. Oh, interesting. Well, now that I'm looking at this actually, if I were to do that, actually that would be the email right there. Yeah, there's no way for Regex to know that this hello is the email. But basically, if there's any other character in between, it'll only grab like the hello@gmail.com part, right? It'll also do any number of these here. So the rule is it'll only match characters at the end, because obviously characters are the only things that are permissible in like the top level domain endings. If I had a space here or something, it was like an MZ and then a bunch of underscores or something, it would still match my email. If it was this, that would work as well. You could see that we've matched fefe@instagram.io. The reason why is because all of these underscores are considered valid characters to have in an email address. If I did a space or a backslash or something like that, if I deleted these, then yeah, we'd still match it. The reason why I'm just running you through this stuff a bunch is because the best way to learn regex is just to play around with it and just to get an intuitive feel for, okay, what happens if I press a period right now? Well, that's going to match any character. Okay, let me think. Like if we match any character next to this character, then what's the result going to be? And as you see here, pressing a button and then seeing it update in real time is so much faster than taking this back to make.com and then running it and then checking and then running it and then checking. So if you just get in the habit of using a platform like Regex 101 or Regex 101 to do the testing, you're gonna build your regexes like 100 times faster. But okay, great. So what do we have here? We have our wonderful email string. Why don't we actually pump this now back into make.com? And then why don't I just grab this? Why don't we just see what happens as we run this? So the output here is going to be empty. Now, why is the output going to be empty? Well, I'll tell you why. The reason why is because we didn't have one of these. And so if we didn't have the beginning and the end here, it's not going to work. So I'm going to add these two here. Now we're going to run this. We've now gotten one email, and now you're probably thinking, well, why are we only doing one? Well, it's because if you remember, there was a way to select global match versus individual match, and I turned that off. So if I go yes, I click OK, and I give this a run. Now we've selected, or we've gotten all three of these emails. And if you wanted to do something cool with this, what you can do is you can go down to aggregator, right? Because right now these are all different bundles. What we can do here is we can feed in, let me see, it's the $1. Actually, why don't we do this? That should work a little better. I have to unlink this one more time because I'm trying to get the variable email now. Okay, great. Now I can connect this. I'm going to use the text parser as my source module, and what I want to aggregate is this email. I'm going to run this, and now what we get is we get an array with all of these email addresses, basically, which is great. And we could use this for whatever purpose we want. So yeah, that's how to do emails. As you can see, there's a lot of playing around here, but the main ones to know are period and then asterisk. And then these brackets that allow you to choose any characters. So A to Z, A to Z, A to Z. This is the pattern that you use when you want to match all lowercase and all uppercase word characters. And then, 0 to 9 would also match anything between 0 and up to 9. And if you want to match individual characters, you just go A, B, C, D. You can insert logic here, like I'm matching A, B, C, D or E, F, G, H. So A, B, C, D, E, F, G, H, right? That's going to work for either of them. But we're basically just matching one of these characters. We're not matching all of them, right? We're either going A, B, C, D, or E, F, G, H. And yeah, that's that for emails. If I were to drag this down here now to our final boss is going to be URLs from web scraping. And the reason why I left this blank is because I actually wanted to go out and then scrape and show you guys how to do this in practice. So I have my handy dandy make a request module here. And what I'm going to do is I'm just going to match my own website. The content type is going to be application JSON, and then I'm going to parse the response. And if I give this a run, we're going to get a bunch of HTML, right? Well, what I want to do in this case is I want to really quickly and easily just scrape all of the URLs. If I go HTML to text and I feed this in, check out what the output is. This is my website, leftclick.ai. So this is the exact same thing as what we're seeing, just represented in text. But as you'll notice, there are a bunch of these URLs here, basically. And what I want to do is I want to select all of the URLs, every single one. Maybe I'm trying to scrape all of the files on a website or something like that, and I'm trying to get the URLs. Well, it's a very quick and easy way to do so, and I'll show you how to do this. This is something that I do very, very often. So I'm actually just going to remove the URLs from web scraping. There's no more reason to do that. I'm just going to feed this text parser module in. We're going to do it like this. Oh, and actually, let me think. Do I want to scrape my website every time I do a test? All right, screw it. We'll scrape the website every time I do a test. What I'm going to do is I'm going to grab all this text. I'm going to go over to Regex 101 again. I'll paste this in. And my task is now scraping or pulling all of the URLs. That's what I want to do. So off the top of your head, how would you go about doing this? Well, odds are my URLs are going to follow a similar structure, right? Notice how we're using square brackets here. If you remember square brackets in Regex, this is sort of like a reserved character. I believe that's what it's called. And so if you want to scrape the actual, or if you want to match the actual square bracket, you need to escape them. So we need to do an escape, and then we need to do this. Now what we're doing is we're matching the presence of any one of these left square brackets, which we could see over here. And now basically what I want to do, if you think about it, is I just want to match anything within these square brackets. That's more or less it. Now you'll see that it's not matching everything that I want because there's some other text basically. So I need to find a way not to match that. Let me see. If I match any character ungreedy, that'll probably work. Yeah, there we go. Any character ungreedy. Beautiful. And then what I can do is I could match these, and then I could add a question mark, and then I could say URL. And now we have a group called URL, which is matching all of these. But you'll see that there's some weird sort of patterns here. And the reason why is because some of these are absolute URLs, which store https:// and then the URL that I'm looking for. And then other ones seem to store the relative URL, which is like they just assume that you already have my URL in front of this. So that's okay. If you're trying to store or scrape only absolute URLs, you could do it pretty quickly. All you do is you only look for the ones that have like an HTTP in front of it. And if we do that, now we only grab the absolute URLs. And these absolute URLs obviously store images and files and that sort of thing. So let me actually take this now. Let me pump this into my text parser. The pattern I'm going to be looking for is this. And then the text I'm going to be feeding is going to be the output of this previous module. We're going to run this. And what we're going to get is we're only going to get one. Why? Well, it's because while I was designing that, I forgot to click global match on. So we're going to go global match on. I'm going to run this again. And then now we have basically bundles of URLs. And we can do things with these URLs. And let me just double check to make sure these URLs actually work. If I paste this in, what do we got? We got a Typeform link. Wonderful. This is a Stripe buy link, probably for my subscription service, right? Yes. This is going to be... We are getting a lot of Typeforms. I think that's because I have my Typeform link up like 6 times or something. But, we got our Twitter over here, which is pretty cool. I think if we were to go to the relative URLs would contain images. So if instead of this HTTP, I just go back, then maybe I want the presence of this / and I run this again. We're now going to get all of the relative URLs. And the left click logogram, for instance, if I type in leftclick.a and then paste the rest of that in, you'll see that we actually have access to the images as well. So this is going to depend on the convention of whatever you use to build the website. In my case, I know what I use to build the website. So if I want to collect images, I basically need to just scrape relative URLs. If I want to scrape other ones, then I need to do it in other ways. But I'm sure you can imagine how you now have the toolkit that you need to get out there and start scraping and then converting the data and parsing in ways that you want. Okay, great. So that's sort of how to do it all using Regex 101. And then obviously sort of like your own acumen, just looking at these procedural rules. But the cool part is in 2024, you also have access to AI. So I'm going to use Claude here. And basically what I want to do is, if I want to check whether something like this is going to work, most of the time, the first thing that I do is I'll look for, I'll basically ask Claude to design me something instead. So I'll say, here is a test string. Design a simple regex that matches all of the links in this test string. And as you can see, I'm simply asking it to design a simple regex. You'll see that we now have some result. The thing is, I'm not going to trust Claude 100%. I'm actually going to go and I'm going to verify this myself. You'll see that there are now a variety of errors here. And Claude, I want to say works maybe half the time, doesn't work all the time, maybe half the time. But there are what look like some escape issues, I believe. And I don't think Claude escapes the characters naturally. So I had to go in here and I basically had to look for the presence of all these red ones. And then I just had to manually escape them. Okay, so I escaped them. And then what happened? Claude actually did pretty good. You see that it's not matching everything that I want always. Like it's looking for the presence of this. And the reason why is because I didn't actually give it full URLs. So it did an okay job, didn't do the best job, did a pretty good job. But the cool part is you can actually have it explain to you what's going on. Simplify this. So instead of capturing links that begin with a \, we capture anything between the 2 brackets, 2 square brackets, simpler. Also, make sure to escape your reserved characters using \. It's going to apologize. Thank you, Claude. You're very demure today. And then we can take this back. And then, within like 2 little iterations there, Claude was able to design a regex that actually works and, does a pretty good job. So yeah, I obviously wanted to show you guys how you could do it yourselves first before having to rely on our AI overlords. The benefit too, to just knowing a tiny bit, even a smattering, even this 30 minutes or whatever of regex video is when Claude gives you an output, you will now be able to dissect the output use a specific tool like Regex 101 and then go through and hover over every character and be like, this is what that does. That's what that does. Okay, I sort of understand it. And personally, if you have been with me, if you're still with me up to this point in the video, this is all the Regex that I personally use on a day-to-day basis. I really don't know anymore. As you can see, you could get to a similar level of understanding or potentially mastery in, I don't know, just a few hours or so poking around with it. I hope you guys appreciated that video. This is the exact process that I follow every single time that I'm tasked with parsing something in a big string. It's super simple, and it's something that you do not need to be a programming pro in order to get up and running with. If you have any questions about what I showed over here, just leave a comment down below. I'm more than happy to get back to you. Otherwise, if you could do me a big favor and like, subscribe, get me to the top of that YouTube algo, and I'll catch you on the next video. Bye-bye.